So, yeah, so the first session this afternoon will be looking at the Archer2 development environment. This will probably be quite useful if you've never used a Qos system before. As I mentioned early on this morning, Qos systems are a little different from most. You won't be developing software in the same way. I think it works out well, but there's just a small initial hurdle to get over. Then after our afternoon break, we'll then be moving on to running jobs on the system through Slurm. So getting going, this first session, how long is this meant to run for? Let me double check how much time we have here. So we've got about an hour and a quarter for this session, yeah. So we're going to be trying to find out what the development environment looks like, how you access different components. These components will really be different modules, different versions of software, libraries and tools. How do you change between them? How to find out what's available, how to change your environment for reuse, and how to get help with it. At the end of this, we really want to understand LMOD modules. This is a little new as well. Even if you came from the 4-cabinet system, we changed that for the full 23-cabinet system of Arch2. Find out what's installed, how to get help on it. So as I just mentioned, Arch2 uses the LMOD system to provide access to different software and different versions of that software on the system. If you've used any HPC system or any cluster at all before, there's a very good chance you've used environment modules in some form. Environment modules, the underlying software can come in a few different flavors. What we're now using in Arch2 is this LMOD. This is the most modern flavor, I think. LMOD, L is Lua, so Lua is a scripting language. So these are Lua modules. They just offer some extra functionality. They allow for hierarchical modules. If you're aware of what they are, you don't need to worry if you have never heard of this. We'll see what that means below. Just means that we're using the most up-to-date, most feature-rich version of the software on Archer2. So when you log into Archer2 and do absolutely nothing, so that's what I've done on the right, I've logged in to the system. I logged out just before lunch, I've just logged in again, and I've done nothing else. So this is a clean environment, if you like. So when we log in, we'll find that we do actually get a default set of modules. These are going to include the Qos compiler environments. This is CCE, the Qos compilers mentioned one of the sessions this morning. We also have the Qos mpitch library loaded to provide MPI. We also have the Qos libsci library. Well, actually, this is a collection of libraries. It includes BlastBlax, LAPACK, ScalaPack, and the like. The sort of very widespread numerical libraries. We also have a lightweight performance analysis toolkit loaded. We'll talk more about that tomorrow when we go over profiling on the system. And we'll have some system modules loaded, which are ones which we don't necessarily know much about as users, ones which we don't really need to care about. They're there to ensure that pieces of hardware can be used, essentially. So we can run module list, and I'll just do the same here to show you. Module list will show us what we have loaded initially on logging in, and you'll see that these should be the same. I don't believe there have been any software updates since I put this in. So yes, so some of these we can see what they are. So we've got CCE, there are the Qos compilers, Qos PE, this is some system module to make sure that our modules are actually working. Qos PE, again, we've got some of these libfabric. We don't need to worry about these so much for now. perf tools are the performance analysis tools. xpmem, we don't need to necessarily worry about that. Things which we do maybe care a little bit more about as developers here, as users, are cray impitch is loaded, cray libsci is loaded. We'll see what this means per again of cray, and then just a few more which EPCC have installed to help keep the modules in order. Sometimes if you've done this before, if you've used modules before, you might have used the module purge command to essentially clean everything back to an empty state, get rid of all the modules that you currently have loaded. Because of the very interconnected way that the cray modules work, all of these modules, they generally rely on one another, and a lot of the system functionality is based around you having some of these installed, having some of these loaded. If you were to purge them, you might find yourself essentially working in an unusable environment. So you generally should not do that. If you do need to, if you want to change the setup, generally go through a module load or module swap. Or if you really do need to restore things, you should be able to run a module restore command, which will set things back to how they were when you logged in. And if everything really is broken, generally you would just want to log back out and log back in again to get back to this initial state with the modules, and then you can start loading or swapping as necessary again to get the modules which you want there and ready for you to use. So that's our first command. We're going to go through a few different module commands, understand how we can use it to work here in our software development. So we've seen module list, shows us which modules we have currently loaded, but of course there are going to be many, many more which we want to use. We maybe want to swap some of the ones we already have loaded out for different ones. So to find out which ones are available, we can use the module avail command. This is actually shorthand for module available. So you can do module available and it will go through everything. Or we can do module avail. Generally, just go for module avail because it's a shorter command to type in. So if we do module avail, we now have this. Let me make my terminal a little bit bigger. And now we've got lists of all the modules here available on the system as it is just now. The things which we can load now if we want. See, some have Ds and some have Ls by them in yellow. If it's got a yellow L next to the module name, it means that module is loaded at the moment. If there's a D next to it, that means that if we were to load the module without the version number, so you can see here, say we've got two different progenv AOCC modules, we'll see what that means later on, but we've got progenv AOCC 8.0.0 and 8.1.0. D means default, so if we were going to get one without specifying a version number, it would give us 8.0.0 as that's the default. Scroll past all of this. An awful lot of them, aren't there? Yes, as I think we mentioned just before at the end of the first session, some of the things on here, although there are modules available, what we can't necessarily do is actually use all of it. So let me try and find, here we go. So all of these modules are organized. You can see actually here, Archer2 lmod libs core. So these are all libraries which have been installed by the CSE service at EPCC. Archer2 lmod apps core. These are all software applications which have been installed by CSE at EPCC. We've just had a question from Monica. So the difference between module list and module avail is that it gets more details for that command. No. So there are a lot of modules on the system, but you will only ever have probably a small fraction of them loaded. So, and the module avail command shows you what is available to be loaded, but not necessarily what is loaded. And module list will show you what actually is loaded right now. And until a module is loaded, you won't be able to use it. So I can quickly give you an example. So here's code Saturn. That isn't loaded at the moment. So if I do module list, it's not there. And there's a code Saturn command that it provides. And if I do code Saturn, commands not found. And then do module load. I think we'll be talking about this a little bit further down the page anyway. I can then tell it to load that module. If I now do module list, we'll see the module's been loaded. And I should now be able to do code Saturn. Let me just add, I think it's -- help. And now it's finding it. So without that, we can't actually use the software. So module list shows us which modules have been loaded and are available for us to use right now. Module available shows us what we can load if we want to, but not necessarily what is available now. And then you can do module unload code Saturn. That will get rid of it again. So what were we talking about? We were talking about software available. Yes, so you can see here, if I just do module avail, we have 3 different VASP modules, one version of VASP 5, two versions, sorry, of VASP 5, and one of VASP 6. So this is showing us that the modules are available. However, we can't actually use them, or at least I can't, because I haven't been given license information or anything on this account. So while I can do module load VASP 5, so on, that will work, I won't actually be able to use it because when I run a VASP command, I'll be told I don't have permission. So to get that, you go through the safe, provide your license details, and that those permissions will then be applied to your account. And then when you load it, you'll find you will be able to use it. If you want help on what some of these modules are, you can use the module help and module what is commands. So let's just take a look again at what we have loaded. So there's an example here for cray mpitch. So you can see we've got cray mpitch loaded. Let's just try and do module help cray mpitch, and we'll then see we've got some help, we've got some license information, then a general description of the purpose. We can tell when it was released. It's based upon ANL mpitch 3.4a2 with support for libfabric, optimized for the Cray programming environment. Some more release notes, actually fairly detailed, isn't it? And it tells us which compilers, which versions, dependencies. And we can do the same. Well, let's try and do module what is. It's a much briefer description, cray mpitch message passing interface. You should be able to do that for essentially anything. Let's try and do CCE. Find the system part and environment variables needed to run the Cray compile environment. So a very brief 1-2 line bit of text to tell us what that module is actually there for. So I've already just shown this, but the module list, we can see we've got all of these loaded. we've got Cray libsci loaded, which provides BLAS and LAPACK and the like. One of the sort of very commonly used libraries it doesn't provide is FFTW. We can actually see, if we do module avail Cray FFTW, it will show us which Cray FFTW modules are available, and we can see we've got 2 Cray FFTW modules available. So that means we can now do module load Cray FFTW. Check in module list, and we've loaded the default version. Remember, this one's indicated with the D. So 3.3.8.9 was the default, not the other 3.3.8.11. So when we did module load Cray FFTW, we got Cray FFTW 3.3.8.9. If we did want the other version, well, let's first of all get rid of that. I can actually show you. No, let's just unload it. So we'll do module unload Cray FFTW. Something I'll note, if you're used to using tab completion while going through your directories on Linux, tab completion does work as well for modules. Although we don't see it when we do this, these are actually paths in a set of directories containing what we call module files. So you can actually do a tab completion. I can do Cray FFTW, and it will then know that, well, it's Cray FFTW, and if we want to unload one, it's got to be 3.3.8.9 because that's the only one which we actually have loaded. So it will auto-complete that with a tab press. And then we can unload it, and then, well, let's load that other version, Cray FFTW 3.3.8.11. And now that's been loaded. See, we've now got that one. There's a convenience command called ML. This is a shortcut. It does 2 things. The first one is if you just type ML and press enter, it runs module list. And if we do ML, and let's just do code Saturn again, now does module load code Saturn, so it's context sensitive. ML by itself is a shortcut for module list. ML and then the name of a module gives us a module load, and then that module we can do again ML, and we'll see that we've got code Saturn now loaded. So those of you who've used modules before, this is probably all old news for you. Something that may be new if you haven't used LMod in particular before are hierarchical modules. These really are a little bit different, and they can be a little confusing to start with. So let me just, to make sure we're starting from a good point, I'm just going to unload both our 2, module unload, not load. I'm going to unload Cray FFTW and code Saturn. Get back to state. So this is essentially what we logged in with. Excuse me. So let's just read through this because, as I say, this is a little complicated and I want to make sure everyone can get this. Hierarchical modules mean that when you do a module avail, it won't necessarily show you every module that is installed on the system. What it will show you are the modules which are available to load at the moment with your current environment. What determines your current environment is the list of modules which you have loaded at the moment. So if we were to do a module avail right now, which I've already shown you a few times, it won't, as I say, it won't show us every single module on the system. It will just show us the ones which are available based on these modules here. why does that matter? Well, let's imagine that there's a module which maybe depends on which version of MPI we have installed. I'll just pick MPI as an example. We'll work through another one on the left, but for now, let's imagine that we've built some application, and it's going to depend on whether we've got Cray MPitch 8.1.4 or Cray MPitch another version. If we didn't have Cray MPitch loaded, it wouldn't know which version to offer us. It wouldn't know whether to give us the version of the software that we built for 8.1.4, or it wouldn't, and it wouldn't know whether it should instead offer us the version that we built for 8.1.2, say. So until we loaded one specific version of Cray MPitch, it just wouldn't show us that module. Once we did get one loaded, it would then go, aha, so you want the one for version 8.1.4. Okay, here's this other module if you want it. So to try and demonstrate this, we're going to use the example of Cray netcdf. If we do, so I showed you how modular avail, remember, if you give it the name of a module and then do modular avail that name, it will just show you which versions are available to load. And it's actually kind of giving a hint down here as to what we need to do in the next step. But for now, let's just take a look and say, module avail Cray netcdf. So, of course, I think I mentioned above on the previous one of the previous sessions this morning, some of the Cray provided software includes netcdf, HDF5. You've probably heard of these libraries to help with I/O, with writing data to and from, writing data to files, reading it from files. netcdf is one. Cray netcdf is the special Cray version we have. So let's take a look. And we do actually find these two. Let's not worry about these. These are special installs for AOCC, so let's forget about those. But what we don't have are just Cray netcdf files, Cray netcdf modules. But down here it's saying, and this is what we're going to do, use module spider to find all possible modules and extensions. So what we do is we'll do module spider Cray netcdf. And now we've actually got some more information. And it's telling us that some Cray netcdf modules do exist. We've got two, 4.7.4.3 and 4.7.4.7, and other possible matches. We saw this one, which we're not going to worry about, and there's a Cray netcdf HDF5 parallel as well. If we want, we can use some wildcards to expand our search. We're not going to do that just now. We know that we're looking for a Cray netcdf. So we know that the module, that these modules exist, but module avail isn't showing them to us. And if we try and do module load, let's just pick one of them, we'll see it fails. And that's because it isn't available at the moment. Module avail isn't showing it to us. We can't load it. And again, Lmod is giving us a hint here. They can't be loaded as requested. Try module spider to see how to load the modules. So that's what we'll do. So let's do module spider. And which version do we do here? Let's do the different version. Let's do 4.7.4.7. Let's do the whole thing. So we're saying module spider now, Cray netcdf 4.7.4.7. Now we get some more detailed information. You'll need to load all modules on any one of the lines below before the Cray netcdf 4.7.4.7 module is available to load. So we've got a lot of lines here. see one for AOCC, CCE, then lots of GCCs. And then on the right-hand side, some Cray HDF5 modules. So this is saying we need to have all of them on any one of these lines loaded. Well, let's take a look. If we do module list, or just ML equivalently, well, we can see we've got CCE 11.0.4. So that's this here. So it's saying we need to have in this line the Cray compiler loaded and also Cray HDF5 1.12.0.7 loaded. What we don't have loaded is that Cray HDF5 module. So what we're essentially seeing here from these lines is this is telling us that to load Cray netcdf 4.7.4.7, we need to have a compiler loaded. That's fine. We'll basically always have a compiler loaded, but we also need to have one of the Cray HDF5 modules loaded. So a decision has to be made. Do we want to load Cray HDF5 1.12.0.3 or Cray HDF5 1.12.0.7? Once we've decided which Cray HDF5 version we're going to use, then we will be able to load Cray netcdf 4.7.4.7. And that's purely because there is a different version of this Cray netcdf 4.7.4.7 for each one of these combinations, because Cray netcdf depends on these, depending on which compiler we're using, which version of which compiler, and then which version of Cray HDF5. This is going to give us a different Cray netcdf. So we know that before we can use Cray netcdf, we have to load a Cray HDF5 as well. So let's just pick this version of Cray HDF5, and we'll do module load Cray HDF5 1.12.0.3. We do module list again. Here we go, Cray HDF5 1.12.0.3. Now let's try doing module avail Cray netcdf, because we think now we should have fulfilled the requirement. And if we check, it's now telling us we actually have a choice. Both of the two different versions of Cray netcdf are now available for us to load. So we can just, I think I said we were going to go for this one, the non-default one. So we can do module load 4.7.4.7, enter, and that's now worked. And if we do module list, we have both Cray HDF5 and Cray netcdf. So this is as I say, I think this is a little odd if you haven't come across this before. I think the main thing to take away from this is that if there's a module which you know exists and you can't see it under module avail, try a module spider for it instead. And if you just want to search through everything anyway, if you just want to see not just which modules are available to load now, but which modules are on the entire system, do a module spider instead. And that will search through, and it will tell you if that module exists. And if you want to know how to load it, just run module spider with that module's full name to find out how. Check against the modules which you have loaded, and you'll see that probably one of them is missing, or one or two of them are missing. Load the ones which you're missing, and then you should be able to load the one which you're actually after. Okay, at this point, does that make sense for everyone? Because I do think this is a little unusual if you aren't used to it. So if you have any questions at this point, please ask. Okay, great. I'm glad that's helpful. I think it's nice to see a demonstration of this in practice, because it's a little wacky, but just seeing how the version of HDF5 matters, and it's only once you've made that choice you can grab Cray netcdf. I think that helps in understanding this. Okay, if there are no questions, then carry on. There are some more things to do, so we'll start to talk a little more now about the other modules that are available, some of the ones which are maybe less obvious. So one of the ones which you'll probably not be familiar with at all if you've never used a Cray system before or never read about using a Cray system before are these progenv modules. And if I do module avail, you should see, let's just do module progenv avail progenv. We'll see there are actually a good few of them available. So these progenv, as they say, modules are what are generally termed programming environments, and this is where the whole Cray ecosystem of software comes together. When you load a specific programming environment, so we just pick any one of these 6, and you can see we've got programming env Cray 8.0.0 loaded at the moment. What you're doing is, at the most basic level, you're choosing which compiler you want to use. But it's so for Cray, you're saying I want to use the Cray compilers. AOCC, this is the AMD compiler, remember, AMD optimizing compiler collection. Or you can just go for the GNU, which gives you Gcc compilers. But when you choose to use one of these, you're choosing not just to use that compiler, but all of the other modules. And at this point, we've got quite a few of them loaded. All of these will also be changing to use the correct versions of the libraries which were built with these compilers. So at the moment, with our you can see we're in progenv Cray. We've got the CCE compilers loaded. This means we'll be using the Cray compiler versions of basically everything here. If you want, you can swap to another one. So if we do module load progenv GNU, you can also do a module swap. I prefer to do module swap just to make it more explicit. So you can do module swap progenv GNU, and then you can do progenv AOCC, module swap progenv AOCC back to progenv GNU again. I think it just makes it a little clearer to say I want to remove this progenv and then load this one. Swap is basically, sorry, I should actually say what swap does. Swap is a combined unload and load. So when you do module swap, you then give it the name of two different modules, and you're saying unload the first one and load the second one. And you can also do this for versions. So you could swap from one version of Cray netcdf to another version. Anyway, so I'm getting a little bit off track. So what we've done here is just what we've done on the left. So we've swapped into progenv GNU 8.0.0. That means we don't have CCE anymore. Instead, we've got GCC. More than that, if there are any system-specific modules which are needed for one of the compilers and not for another, they will be changed in and out as appropriate. As I say, things like cray mpitch will now be pointing to the GCC compiled libraries rather than the cray compiled libraries. Cray ellipsi will be using the GCC versions, or the versions of BLAS and the like built with GCC rather than the versions of BLAS and the like built with cray. Everything will be swapping itself in and out correctly and reorienting itself around the programming environment which you choose. I won't go into that. Okay, it's covered down below. So yes, so if you want to change from cray to GCC, a lot of people do just go straight for GCC. When you log in, it's really just a matter of doing module load plugin, and that's it. And you run that, and that will swap you to the correct plugin. There are different versions of the plugins. If you look, I wouldn't worry about those just now. We'll sort of touch on those a little bit in a minute. But yeah, for now, it's enough to just say, just do module load or module swap, as I say, I prefer. So plugin GNU to plugin cray will take us back to the cray environment once more. And now we're ready to use the cray compilers rather than the GCC compilers. I should just say, just out of interest, because some probably, since I guess you are all software developers, I think a lot of people do go initially straight to the GCC compilers, but I mean, because basically everything is guaranteed to build with GCC. But at the same time, I've found that the cray compilers are actually rather good, and I found that in certain circumstances, I'm seeing better performance in terms of MPI communications with the cray compilers. That won't be in everyone's case, but certainly if you're writing code with lots of collective communication, I think it's worth giving them both a go if you at all feel you have the time to spend on seeing if it will build and work with cray, because chances are it will. It's still just well, cray is the cray compilers are the cray Fortran compiler is proprietary, it's their own. The cray C and C++ compilers are built on top of LLVM, so it's still just ultimately a normal compiler, but it's worth just, I think, messing around if you are at all inclined, just to see which one gives you better performance. Okay. Yeah, so this is what we've seen as a byproduct of us swapping programming environments. We've seen the actual compiler modules change. So again, let's just show this once more. We've got CCE 11.0.4 loaded, and in fact, if we just do module what is, I think we did this earlier, 11.0.4, just to be explicit about it, and it will tell us that this is the module which gets the cray compiler environment working for us. If we then do a module swap of plugin cray for plugin GNU, so we're switching back to GCC again, we'll now on the module list see that our CC has been replaced by GCC 10.2.0, and we can do a module what is again, and that should, that's basically the exact same text but with cray compile environment, so it swaps out for GNU compiling environment. So these are the modules which are actually giving us the compilers. if you've used non-Cray clusters, you've probably just been doing things like module load GCC 9.3.0 or module load Intel compilers 18 or the like, just to load the compiler. Except here, remember, we're doing it all sort of through the programming environments to swap between different flavors of compiler. So we've got our GCC 10.2.0 is what we've got by default when we swap from Cray to plugenv GNU. What if we want to use a different version? So just as we can see here on the left, let's try and just swap out that version of GCC. Remember, swap is a combination of unload and load, and if you unload and then just give the module name without a version number, it's intelligent enough to realize that you just want to unload the version which you already have loaded, because what else can you do? So module swap GCC, GCC 11.2.0 means it's going to unload the version of GCC that we currently have, which is 10.2.0, and then load 11.2.0. And that will do it. And if we do ML to take a look, we can see we do indeed now have 11.2.0 loaded. So this will work, but I'm not certain I would necessarily recommend this. There is a better way of doing it, though it takes a couple more lines of module loading and the like to get going. And that's to rely on a CPE. So this is a Cray programming environment release. So essentially all of the Cray modules here on the system that we would get if we were to module avail or module spider them are released together as part of a CPE release. These are generally these generally have versions referring to the year and the month. So if we do module avail CPE, you should see that, oh, there's a CUDA one. I wonder what that's doing on there. We've got CPE 21.04 and CPE 21.09. See, CPE 21.04 is the default. So when we log in, all of the modules that we get are drawn from the 21.04 release. So this is April 2021. But if we do want to switch to a newer version of the software, what we can do is we can load the new release. So let's just do this. Let me just show you. If I go back to module load, module swap, let me do it properly. Plugenv GNU, and let's just go back to plugenv Cray and then back again to client for plugenv Cray and then back to plugenv GNU. And if I do ML, we should, yes, so we're back now at GCC 10.2.0. But let's say now we aren't just going to do module swap GCC for a newer version. Let's try and swap everything, all of these modules for the newer software release. To do that, you just do module load CPE 21.09. And this, as you can see, is going to reload a few things with newer versions. It's swapping our plugenv GNU version from 8.0.0 to 8.1.0. It's bringing us to a newer version of Cray HDF5, newer version of Cray libsci, Cray mpitch. The Cray PE version is updating, and the GCC version is changing from 10.2.0 to 11.2.0. One last thing you should do at this point, and it's a little bit annoying, but we've just got to add this line where we're adding the Cray LD library path environment variable onto the front of our existing LD library path environment variable to make sure that the new ones from the new CPE are being used preferentially when we're going to build. Just in case you forget this line, it is in the documentation. I double checked that on the website. So this was, I think I would recommend doing this over just, you know, switching to plugin GNU and then loading the version of GCC that you want. I would recommend changing the CP as a whole, because now we're making sure that we're getting not just the new version of GCC, using 11 rather than 10. We're also getting the newer versions of Cray HDF5, Cray libsci, Cray mpitch that were released as part of this this full CPE release. These are guaranteed to be compatible and to work with one another. How's the time doing? I think, how are we doing against the schedule? We should probably be aiming to finish. Okay, we've got about another 20-25 minutes left of this session as scheduled. Something else to take note of, and this is another thing which I think can really throw people off the first time that they get onto a Cray system. You're probably used to, if you haven't used a Cray cluster before, you're probably used to using makefiles or CMake or whichever build system you use, by just telling it to use GCC, gfortran, ifort, whichever compiler your code is usually going to use. What you should not do on a Cray system is call the compiler directly. So what I mean for that is that you shouldn't do gcc source.co-o-exe. I'm just gonna words. You shouldn't be building code like this. Instead, what you want to do is use the Cray compiler wrappers. The compiler wrappers are just scripts, essentially, provided by HP Cray. They are an intrinsic part of the progenv modules, and what they do is they are, again, module sensitive. So they know which modules have been loaded, and they know how to link in everything from those modules. So again, if you build MPI codes, you're probably used to doing things like MPI for, say, if you were building with Intel MPI Fortran code, because MPI Fort calls ifort, the compiler itself, and it will add in all the options to correctly link in the MPI libraries. The Cray compiler wrappers go even further in that they will correctly link in your MPI libraries. They'll link in libsci, they'll link in essentially everything that you've uploaded. So all of these modules which provide libraries, which is the majority of them. I think libfabric provides libraries, DSML, HDF5, libsci, mpitch, netcedia. These all provide libraries. When you call the Cray compiler wrapper, it's aware of these and it knows how to link them in. So you don't have to do the perhaps laborious digging around for paths and setting of options to the compiler to do that linking yourself. So you wouldn't do, in the case of, let's imagine you are building a Fortran code. If it were a regular code, you might just be doing, say, gfortran. You would do gfortran. Let's just call it source.f90, and you're going to call it exe. Let's just go with something like that. That's how you would do it. And then you would be doing -l, and you'd be adding all your options to add your libraries to it. If it were MPI, you'd probably be doing something like MPI F90, because you know that that exists. On Archer2 and any HP Cray system, Instead, you would just do ftn. ftn is the name for the Cray Fortran compiler wrapper. ftn is aware that we are in we're in Prog-N of GNU 8.1.0. It will call through to gfortran 11.2.0. It will then correctly link in all of the libraries from all of the loaded modules, and that's all that we would need to do. We'll be doing this a little ourselves later on in the course. You'll see that calls to the C, I think, compiler wrapper are being made, and in every case, you should always use the compiler wrappers to make sure that the codes are being built correctly. There may be edge cases. I think there are literally a small handful, single-digit edge cases I think I've heard of, where calls directly to the compilers are necessary. But I really think they are edge cases, and everyone should be assuming in the first instance that you would not be doing GCC or whatever. You would be doing DC is the name of the C wrapper, and if you were doing C++, capital CC. This would always be what you should do. And unless you find that there is something very intrinsically broken about how this works with your build script, I would do everything to try and ensure that you use these wrappers to build correctly. What this often means is you would often just do you would either export as environment variables or just set these as variables before calling CMake. You would just set that these wrappers should be used. So you would just start doing export CC equals CC. That's unfortunately a little confusing, isn't it? CC means C compiler. You'd then maybe be doing export CXX equals CC to tell it to use the C++ compiler wrapper to build C++, and you'd be doing export MPI CC equals CC just the same again to tell it to build MPI C codes with the CC wrapper again. And again, and you do exactly the same. You would be doing for G4tran, you would be setting export MPI F90 equals FDN or FC or maybe F77. I've seen different scripts do it different ways, different make files do it different ways. And if you were using CMake, you could just do CC equals CC CMake dot or whatever the path to the CMake list the text file is, to let it know that you would want it to use the CC compiler wrapper. Again, I hope that makes sense. We'll see it in action through a make file or two when we do at least the debugging and profiling exercises. Yeah, and I should say, there are man pages available, so you can always get them. So you can obviously access G4tran to see the regular options to G4tran. Again, not that you would be using G4tran, you'd be using ftn still, but you can also do man ftn to see what you can see here. Invokes the Fortran compiler in the currently loaded programming environment, and it will tell you specific options to the ftn compiler wrapper. And if you're in the Cray environment, you want to look at CC and Cray FTN, Cray CC and Cray FTN to see the options for those compilers. I should say for dynamic, for how to link, Dynamic linking is default. I think some people have tried to do static linking. I think it's more trouble than it's worth. Everything now is built around the assumption that you'll be doing, you'll be linking dynamically. It's also configured through the compiler wrappers that everything will be built with a run path. So that means that the executables and libraries that you build will include in the header sections of the files the paths to the libraries needed to run them. So when it comes to running your executables or using your libraries in a job, you don't need to spend time setting up the same module environment before you run. You can basically skip that, just call your executable, and because it knows where the libraries are, it can just go ahead and look them up through the linker. You might be aware of something called an R path. You might have heard of that. There's a slight distinction between a run path and an R path. They both do the same thing, except that there's a difference in precedence between them. And an R path, if it's present in an executable library, means that the linker will always use that library. Run paths have lower precedence. So if there's a library in a run path, but then inside LD library path, it finds the same library, but maybe in a different location or a different version of it. Say the version it's found in LD library path will take precedence. So you can build with run paths, and if no other information about the library is given in LD library path, it will just use the one from the executable R path. If LD library path does contain a newer version, or a different version of the library, that one will be used. So you can essentially, at runtime, with a run path, change the library still that you want to use. Unless, yes, and this is an important note, because the CSCT modules, which will be the, let's just do a modular veil quickly. You can see here, and it's in the documentation again, you can look them up. Yes, so these are the CSC Archer2 Modlibs core. These are the CSC provided libraries. So if you use any of these libraries, you will need to load them in a job script to make sure that the environment is aware of them before running them. And that's because these aren't pieces of Qos software, or rather these aren't pieces of Qos installed software. The compiler wrappers don't actually know about these. They don't know to put the run paths in place. Finally, just to say, Archer2 documentation is there on the internet. That goes into much more detail than we have time really to cover in this course. So if you are interested or want to know more, and I imagine probably all of you will at some point, because if you're developing code, you're always going to be running into strange situations, aren't you, where something isn't working or you want to know a little more about something. The Archer2 documentation is there and does include information on the software provided by both Cray and EPCC. And finally, if you do run into issues still and just aren't sure, or if you have any questions about any of it, or do run into any problems, or maybe even run into bugs, it's possible, please get in touch with the Archer2 service desk. You can just send an email in and we'll get back to you and help you with it, either answer your questions or help you fix the issue that you're facing. So the key points are that We control the development environment through LMod modules, similar to older versions of environment modules, but with the added hierarchical module bit on top of it that hides some modules until it knows how to load them. We support the GCC and Cray, and I can see that needs an AOCC to be added because we have the AOCC compilers now, although I think the GCC and Cray are by far the most popular compilers to use. You should always try to use these through the FTN, CC, and capital CC wrapper commands to make sure that the compilers will be used correctly with all of the Cray software that's provided, so that you'll be building correctly against the various bits of software supporting the hardware and the like. And if you need help, yep, you can get in touch with the service desk, and CSC service will be able to help you solve whichever problems you're having or whichever questions you have. Okay, so we've actually done pretty well there. We finished about 7 minutes, I think, ahead of when I was expecting us to get to this point. There's a lot of information there, I'm aware. How does everyone feel about that at this moment? So we'll be seeing some examples of building with the wrappers in the examples when we do some runs. Okay, Mike says all good, thanks. Okay, great. Okay then. So what I'll say then. Okay, great. Everyone seems happy with that. Perfect. Okay. So let's see. I think let's try and stay on schedule. So if we take a 15-minute break now, then we can come back at 2:30, and we'll have the final session of the afternoon, where we'll talk about Slurm. So here we'll be submitting some jobs. We might overrun a little on that because someone, sorry, I've forgotten who, was asking about using the data analysis nodes. Ruth was asking about the data analysis. Yeah, so I'll try to talk about that a little during that session. So we may overrun by 5 or 10 minutes on that, but we'll still be finishing, I will expect, probably no later than 3:30 today. Okay, so yeah, so let's call it just there for now. Just for 15 minutes, we can go away and get another drink of coffee or whatever if we feel we need some more caffeine. I still feel I need it, even though it's 2:15 in the afternoon. And okay, great. I'll see you back then in 15 minutes. Hey again, everyone. So let's get going then with the final session of the day. Let me just bring my screen up. There we are. Well, hopefully, there we are. Perfect. Perfect. Okay. Okay, so we're actually going to be running some jobs in this session through Slurm. As I mentioned, we have a reservation which we can use. So there are some nodes set aside for us on this course to use when running these jobs, which will help us make sure they actually get through the queue. So coming into Archer2, probably having not used it before, we want to know a few things. How do we write scripts which we can use to submit our jobs to the queue to be run? How can we control them once they're in the queue, or running indeed? And how can we find out what resources are available? So we want to understand some basic Slurm commands, know how to get through the Archer2 scheduler Slurm, and know where to look for further help on it. We'll actually probably go through a manual example, if you like, of the last one, because we're going to look at how to run on the data analysis nodes. So yes, Archer2 uses Slurm as its scheduler, which is the system used to submit jobs, to work out when they're going to run, on which nodes, to end them, and also it's used to launch the MPI tasks. Not all job schedulers do this, but Slurm here has been built to be cluster aware, it's MPI aware, it will do the launching itself. So we're going to be using a few different commands. sinfo tells us about the nodes on the cluster. sbatch is how we submit them. sq lists jobs waiting in the queue, those running. scancel is used to cancel them. salloc and srun have kind of overlapping uses slightly. salloc is one way of running interactive jobs. srun is used to launch the parallel tasks within a batch job script, and also can be used to submit an interactive job session in a similar but not identical way to salloc. We'll cover that a little. It's full documentation as ever, and we'll be looking at that later on in this session. So let's start out then. Let's find out what resources are available. We just said that. sinfo queries the current state of nodes. So here's our very first Slurm command. You probably also noticed here, they all begin with S. There are actually a good few more Slurm commands, but they all begin with S, so it's thankfully fairly simple to remember what's a Slurm command and what isn't a Slurm command. So here we are again. Let me just scroll past all of that. I'll just clear it. On our prompt, here I am again, still on my account for this course. I'm on login node 04, and let's just run the sinfo command and see what happens. And we've got a lot of information, which is very obviously a little difficult to parse as it is. So I'm just going to quickly scroll down to a point here. We have got some very wide tables here. Making sense of what's here is quite tricky. So what we're going to do is I'm just going to actually pipe my sinfo output to a command less-s. You may have used less before, or you may have used more, which is a similar command. Both more and less lets you scroll through files, go and take a look at what's in them, or scroll through output from another command. So what we're doing here is we're piping input from sinfo through to less. The -s option says make it single line, and now we get our output looking like this, and we can scroll left and right through it, which is much easier to read, thankfully. We don't have all that horrible line wrapping that we did previously. So now we can take a look and actually try to understand what we're looking at here. So we've got several columns on this table. So first one is partition, and we're seeing that there are nodes in several groups here. So we've got several standard groups of standard partitions. So we can see that although when we were talking about the nodes in physical terms and the compute nodes in physical terms, we had them in two groupings really. We had the regular nodes, we had the high memory nodes, and we had the data analysis nodes, and these are all visible on here. So the standard nodes are just the ones with regular 256 gigabytes of memory each. High memory had double that, 512. And the serial, well, these are the data analysis nodes. So these are in what Slurm calls partitions. And it just means which partition of the compute nodes is a given node in. These are all up, as we can see. There are time limits, so these are maximum run times. These can be related to partitions, but as it notes here, we don't actually set them by partitions, so we don't say every node on standard can only run for up to 1 day. We actually control that. We actually override that through the QoSs, which we'll talk about in a wee bit. You actually see, oops, I missed that. See one standard and one higher mem partition more. Have I scrolled up or down at all? In terms of total numbers or extra lines, they could be changing potentially from moment to moment as these nodes, as different things happen to these nodes. Interesting. I wonder what's causing that. It may be that it may be that I wonder if it could be because we're on different login nodes, possibly. Very possibly. Either way, we can still see for these ones here, we can see how many nodes are in each of these groups. We can see what the nodes in each of these groups are doing. So this is telling us in the first line that there are 10 nodes draining. So these are nodes which are running jobs at the moment, but which won't be allowed to run further jobs because they're possibly going for maintenance or possibly going into a reservation. But they're running and waiting to stop whatever they're doing at the moment. Another drain, some in 103 nodes in reservation on the standard, 5,732 currently running. And then, of course, we can actually see which nodes are in each of these groups. There are many, many, many states. The Slurm documentation, it can sometimes be a little hard to find what you're looking for if you go to the website of ShedMD who make Slurm. But generally, once you've found the page you want, it's fairly comprehensive and it will list every possible state and what that means. So yeah, so we can see all the nodes in all the partitions, how many are in each state doing whatever they happen to be doing at the moment. And yes, we can then go slightly overboard with the next command, and we'll do sinfo -n L, and I will again pipe this to less s. And now we can just see every single node on Archer2, every single compute node, that is, what it's doing at the moment. And as you can see, there is an awful lot of information here. So yeah, you can see there's enough here. If I go back to the beginning, so we can see there are some things which maybe aren't immediately obvious why they're the numbers that they are. CPUs says 256 for everything rather than 128. That is of course because the CPUs allow for threading. So where we've got 128 physical cores with threading, there are up to 256. Probably that's not a good idea. Mixed state. I believe, I'm not certain, we could take a look at this. I believe that is that means that what we're seeing is that the node is partially in use. So DVN01 and DVN02, so these are on the serial partition. So these are the data analysis nodes or data visualization nodes. And that means that as the partition name kind of suggests, probably most people running jobs on those nodes will be using serial processes. So one task only. That means that that unlike all the regular compute nodes in these standard and high mem partitions, on the DVNs, on the data analysis nodes, you can submit jobs and they will just take up one core, and if 127 other people come along, they will get one core each themselves on the one node. So mixed here, I believe, means that the node is partially in use, but not completely. It isn't allocated. So I guess probably there aren't that many people on them at the moment because DVN01 is standing idle. So it's only some fraction of DVN02 is in use. Yeah, so there were 256 CPUs. It's saying that's because they're threaded. So you can, if you want to use hyperthreading. I wouldn't recommend it because you probably won't get good performance. This is kind of explained in the next column. This is a sockets, cores, threads. So this means each node has 2 sockets, each with 64 physical cores. That makes sense. 2 times 64 is 128, and each of those has potentially 2 threads running. But again, you probably wouldn't want to. Okay. So with that, I think we're now coming down to a little exercise for us all. We're going to try and look at the resources available. So if we run this command, so let's just see if this works. If I run this here, it's going to tell us what we've asked for. sinfo, we're saying tell it specifically about node NID 001005. That's just a node name. So this is us talking about one particular compute node. -O means tell us the output on this. We want %n is the host name, %c, number of CPUs. Again, remembering that it's telling us the number of sockets times the number of physical cores times the number of threads per core. And then finally tell us how much memory is available on that node. So you can see in here, we could potentially, and you can check this out as well by doing man sinfo. If you go down to O, I believe it should list, yes, it tells us everything that we can ask for in that output. What we can now do is this little exercise. So the question is, can you find all the free nodes in the system? So basically every node which is in the idle state. That I think shouldn't be too tricky. Let's take 5, 6, 7 minutes to do that. So there are a few ways you might want to go about this. You could try to use bash, and so a few bash commands. You could do it with nothing other than sinfo if you wanted, but I would say try and take a look at man sinfo, see if anything stands out to you. If you just want to find the details of all the idle nodes on the system. Okay, so I'll mute myself and we'll come back in. Let's say we'll come back at about 14:52, so let's give it 6 minutes. In the meantime, if anyone has any questions about this or anything else so far, please do ask. Hi everyone. Okay, so hopefully you've had a little bit of time to look through the Slurm commands here and come up with a solution. It's fairly simple. It's just really a matter of finding it. Or else, if you did want to do it that way, to put together some bash pipes, probably with a grep to sort the states you're interested in. You can see here though, really it just comes down to adding this extra option. So if we take a look down here, well actually let me, this is probably a little bit faster. All we need to do is add a state. I'm going through it too quickly, I think. Add a state option to the sinfo command. So sinfo nl is just what we used before to list everything. So we really should be piping it to less s to make it a little bit more user-friendly, I'll say. And if we just add the extra option, state equals idle to it, then that means it's now only going to show the ones which aren't actually doing any work. See here, some are actually with the reserved state. That means they're in a reservation, but they might be doing nothing within the reservation, is the thing. Drained as well means that they've been put on to drain, so they were running a job and then they finished the job, but now they finished draining, they are drained, but they aren't going to be allowed to start to do any new work until the systems team release them back again. So this is just showing us every node in the system which is at the moment not doing any work. Okay, we'll move on a little then. How to write batch job submission scripts. So you've probably come across this before if you've used any other cluster. So if you've written a PBS script or an SG script, you have seen something that looks broadly similar to this, where in PBS you use PBS options at the top. We've now got SBatch. So our job submission scripts in Slurm have a header section where we specify all the options to Slurm, like what the job's name is, how many nodes we want, how long we want it to run for, how to charge the job. And then beneath that, we put essentially some bash commands that tell the job what to do when it's actually going to run. So here's a very simple example script. It'll run the XTHI program. This is basically a small MPI program that just prints out which processes and threads are running where. It can help you to test with your Slurm options if the threads and tasks are being placed as you think they should be on the node. So for an example here, see we've got a bit at the top that just says, so this is a shebang. You might have heard that term before. It just says this is to be run as a bash script. Then we've got all these hash sbatch lines. And remember, these are the ones which set our options to Slurm. So our first one says that the job name is going to be my MPI job. So that means if we look up the job while it's running, we'll see that name. Then we see we want 2 nodes for it. It's going to run with 128 MPI tasks on each of those nodes, allocating 1 CPU to each of those tasks. If we were running with OpenMP, this would be changing around a little bit. Then we're saying we want it to run for a maximum of 10 minutes. So this is hours, minutes, and seconds. It won't run for any more than that. Then we're saying we want it to run on the standard partition. So remember, we've been looking at these different partitions here. Just do, oops. Yes, again. See, we've got the three different partitions: standard, higher mem, and serial for the regular compute nodes, the high memory compute nodes, and the data analysis nodes. This is just saying we just want to run on a normal compute node. QoS standard, I'll talk a little about what the QoSs mean. It's sort of analogous to a queue. What it really means is we're choosing, we're setting the priority of the job. We can only submit so many to a given QoS. How this also sets the maximum runtime, the maximum number of nodes we can use. QoS sets a few things. We can talk about those. Then we set the account. We're saying we're going to charge the job to our training account, TA051. And then these two final options tell it that we don't want multi-threading. We only want a single thread per physical core. And this distribution block tells Slurm how to place the tasks one after another. So this is just saying do 1, 2, 3, 4, 5, 6 across the cores. If we didn't do this, it would do a round robin type thing where it would paste the first task on the first core, the second on the second core, the third on the first. This turns out to be better in most cases for MPI communication. So that's our Slurm options dealt with. Then we tell it what to do in the terminal, if you like, within Bash itself, within the shell, to actually run the job. First thing it does is it loads the module that provides XTHI. Without that, it wouldn't know what XTHI is, and the job would crash out. We set export OMP num threads equals to 1. This is something extra just to be explicit that we don't want threading. So if there's anything in there that might use threading, don't, just single threads, please. And then finally, we do S1 to launch the executable, which is called XTHI. Okay, yes. So let's try this now. Then let's go to. Let me show you quickly how to do this, and please feel free to do this yourselves if you want. We're going to try running the job together. Here I am in my work directory. Remember, we always want to be running jobs from work. So I'm just going to make a new directory, and I'm just going to call it Slurm exercises. I'll cd into Slurm exercises, and I'll just do make dir first job, let's call it. I'm going to cd into first job. And then I'm just going to write my job scripts. So what you call your job script is sort of a matter of personal preference. I like to give them .slurm extensions, so I'll call mine something like runjob.slurm. Other people will call them runjob.sh. Other people will just not bother with an extension. As I say, they'll just call them run, my first job, whatever they call them. I'm just going to call it runjob.slurm because I just like to have the slurm on the end, because then I can see immediately that that is a Slurm job script. And I'm just writing it in Vim. If you prefer to use Emacs or Nano, whatever you prefer, please go ahead and do it. So let's just try copying this in. So there's my job script. I haven't changed anything from what's here. I am going to do one thing. extra, and that's this bit here, using a reservation. So as this says, we've got a reservation page. So we've got 7 nodes set aside for us to use. So what we can do, and you can do this too, if you are using a TA051 account, but only if you're using an account in that project. So if you're using an account from another project, you won't be able to use this. What we can do is to add this line to our script, and we can then make use of it as it's here. Of course, for this, what we need a reservation code, and I've got these noted down. I'm going to put these in the Etherpad and in the chat, because you will probably be wanting to use these yourself. Let me just put it here. Reconnect. Okay, let's add it here. We've got 2, day 1. The code for the reservation name for today is this. It's a little bit long. And for day 2, tomorrow, it's not active yet, you can't use it, is the same thing very nearly. So today's reservation, this became active at 1 o'clock and it runs until 4 o'clock, is TA051Q1752501. So with that in place, I'm telling it to run specifically on my nodes for this course. And with that done, so you can take a look at it, let's just look at runjob.slurm. I can now do sbatch runjob.slurm. Who's using the reservation? Oh, of course. Res doesn't apply. That's been submitted. We'll go over these commands in a second, don't worry. And that's running. Perfect. Okay. Let me just note this here. Use sbatch. Okay. So you can do this yourselves and you should be able to run these jobs. And that's probably the job finished. Yep, that's my job finished. So the job's run successfully, and we've got some output here now in this file slurm, and that's got the job ID. So while it was running, we sort of had a job ID. When we ran it, it told us submitted batch job 10333520. We've now got a file slurm-1033520. These files by default contain the merged standard out and standard error output from the run. So if we just take a look at it, let's go to more. We can see we've got some output. It's telling us node summary for 2 nodes, gives us the names of the nodes, number of tasks on each, then node, rank, thread. So this is just telling us which MPI task was on which node, essentially. We can see we end up with 256 because it goes from 0 to 255 MPI tasks with ranks 0 to 255 over nodes 0 and 1. So that's our job running. And if you were not using the reservation, so let me just run job. If you weren't using the reservation and you were just running normally, you wouldn't have the reservation line, and you would just be doing Qos equals standard. So that's just you saying a regular job, no reservation, just run it on the standard node, standard partition, charge it to TA051. But because I want the job to run now, I'm going to keep it with the reservation. I'm just going to keep those lines for now. So yeah, so once you've written the job, as I showed you, there's the sbatch option there, command, and you just do sbatch and then the name of the job, and that's what sends it off to be run. So we've got another exercise now. I won't leave you too long. If you don't specify all of these options, so for example, what if you didn't give it a partition, the QoS? What if you just had nothing? You don't have a reservation too. So it's saying to you, try and mess with this, mess around with delete parts of this very basic script, remove or change some of the options to sbatch here, and try and find out what the defaults are. For example, the partition, the QoS, which budget does it charge to, how many tasks per node, number of nodes. The wall time is hard. So I think let's set aside, say, let's set aside 7 minutes for this, and then come back to it. So let's go until 1/4 on this exercise, and then we'll take a look at the solutions together. Again, everyone, I hope you've been able to get at least maybe the first few of these. I will say, yeah, number 5 really is tricky, so don't worry if you didn't get that. So let's take a look through the solutions here, so we can test them out ourselves. So for the partition and QoS, well, I've just deleted them here. So let's see what happens if I try to submit that. Sbatch one job. It will tell me that I can't do it. I have to tell it what the partition is. Well, okay, let's add it back in. Still doesn't like it. It wants the QoS too. So know what we need to do. Sbatch QoS equals standard. That would then work. Number 2, I believe TA051 should be, oops, I didn't actually mean to run that. Let me cancel it quickly. We delete this. So something else you could do actually, rather than just delete them, you can just add some extra hashes at the beginning to sort of comment it out. If I try and submit that, it will actually run. That's because for us, the default account to charge is just TA051. This can sometimes catch people out if they're running in a project which has sub-projects within it, subgroups, and they are meant to use budget from a subgroup. They sometimes don't realize that and will run using the default account unintentionally, and so use budget there. But so I would say always specify the account just in case. I can then cancel this job. So the default. I won't actually show you this just in the interest of time, but to find out the number of tasks per node and the number of nodes, default, you can just run a script like the following. And then from checking the output from XTHI itself, we'll see that we're given one task per node, and one node is the default. The time limit is actually quite tricky. So in this case, what we would want to do is we'd want to use a command called sact. So I probably imagine very few of you, if any, managed to get this in this time. We use sact to query in specific, to query particularly job 1, 2, 3, 4, 5, whatever it might be, 1, 0, 3, 3, 5, 6, 7. sact has actually a lot of uses. You can query a lot of random bits of information you might feel, but about the inner workings of Slurm through this command. We won't talk about it too much here, but it does exist. And you would say, tell me the time limit, and the answer is 1 hour. Okay, so what we can do, we can always use the sq command to take a look at all the jobs running. And I'm just going to pipe this back to less-s again to make it more readable. And we can see there are a lot of jobs running, by a lot of different users, some of them on the standard nodes. We've got some here on the data analysis nodes, some of the high memory nodes. Some of them, well, there's one here that's been running for nearly a day. Some here running over 2 nodes, some with 8 nodes, some with 40 nodes. If you specifically wanted to see some for a particular user, you would do sq -u and then, a user, who of course doesn't exist, so it just gives an error. So you would do that. So if you had a lot of jobs running, so for me, I would do TA051. And because that's my username, and that would then show me all of my jobs. Something which can be useful is to, let's just go back to look at the status. So that's this column here. So this means each job status. So there are a lot here in R. That means they're running at the moment. PD is the other one, pending. So these are jobs which are queued and waiting to run. We may see some in CG, which means completing. No, everything's just running or waiting at the moment. There are a few other reasons you might see sometimes. Generally, those are the important ones, PD, R, and CG. They're generally only in CG completing state for a very short period of time while cleanup is being performed. Then at the right, there's this node list reason. So for a running job, this will show you which nodes the job is running on. Then for jobs which are pending, you will see the reason it's pending. So we've got here some QoS max CPU per user limit, QoS max jobs per user limit. So these mean, I believe this means that this particular person is currently using the maximum number of CPU cores allowed under the QoS, equivalently the maximum number of nodes, so their jobs are going to be queued until some currently running jobs of theirs end, and at that point they'll be back under the limit again and their jobs can run. This person's using running a job which is lasting too long, so they're going to have to wait until that goes down. Priority means that this job is at the top of the queue now. There's nothing stopping it from running. It just needs to be actually slotted into the schedule. We may see some dependency means that you can line jobs up and say this job can only start running when that other job has finished. That's what's being waited for there. We may see some with resources, I was hoping. I don't see any. If you see one with the resources reason, it means that the job is there waiting to go. It just needs to actually wait for the nodes it's going to run on to finish what they're doing at the moment, and once that happens, it will start running. The actual scheduler itself is quite complex. It's quite interesting. It uses an algorithm called the backfill algorithm. Again, the Slurm website, if you search and go there, has quite a lot of detail on that if you find it interesting. Once your job is running, you may find that you have done something wrong, or you don't need that job to run anymore, or you've started it and you want to cancel it to make way for another job. Perhaps you just use, I think I demonstrated it a minute ago, the cancel command, and you just do whatever the job ID is, these numbers here, 103, 174, when it is for that job. So the part of the script beneath the sbatch commands, this is just bash. These are just bash commands: module load, export num30 equals 1, s1 xthi. This is the important part here, I guess. This is the part which actually launches the parallel MPI tasks. In the same communicator, they'll all be ready to run. You might have done previously, you might have done things like MPI run, dash NP 128, say, or whatever. Because Slurm has been built MPI aware, it's aware of MPI, it's aware of the cluster, it's aware of the cluster topology. It's capable of doing the MPI launch itself, while also already knowing how many tasks to launch in which configuration. So you can just do SS run, and it will use all the information that you gave us at the top and launch, in this case, XTHI, with all the necessary information to do that parallel launch. So at its very simplest, you can just do srun and then the name of the executable, assuming that the executable doesn't need any extra options. So think of slow down a little bit. So here's another exercise, but let's just give this, say, 3 minutes perhaps, and then we'll talk about that quickly and then go on to the rest of the material. So here we're looking at underpopulation of nodes. So this might be particular. So really the situation where you might want to do this is if your application in particular needs to have a lot of memory per task, or perhaps more memory bandwidth per task. So in this case, what you would do is you would simply decrease the number of MPI tasks on each node so that there's more memory or more bandwidth available for the tasks which are there. Generally, you'll go down in powers of 2, so you'll go from 128 tasks per node to 64 or 32 or the like tasks per node. Generally, I think people don't need to go down much beyond 64 or 32. So you can think of every time you do this, you're essentially doubling the memory and the memory bandwidth per task. At the same time, it means you aren't getting as much compute throughput. You're halving that to get in return per node more memory per task. Okay, I'll just leave that for a couple of minutes then, and then we can look at the solutions together. So I'll just give that a very short wee while. Okay, sorry, you don't have very long for that, but I want to make sure I don't keep you too much longer than the time that's down in the schedule for today. So let's take a look at the answers. I think this is fairly simple, actually, in comparison to the previous exercise. So really, we're just looking at manipulating the values that we give up here in our batch script to change how many tasks we have running on different units of hardware. So just briefly, the first one, we want to say, well, let's have 4 nodes and 64 tasks per node. That's fairly simple. Just change the number of nodes we want to 4. And the number of tasks per node to 64. That's really all it comes down to. That's just what we've got here. As we make our goal more complex, we need to add some more lines. So if we want to make sure that we have 1 task per socket, then we'll need a new option. So let's just add that, sbatch n tasks per socket. So 1 and 2 tasks per node over 8 nodes. That's all we do there. This is basically going to have 2 tasks on every node with only 1 task on each of the 2 CPUs on that node. And the other 63 cores will be doing, well, unless we're doing OpenMP, probably nothing. The final one is the most complex here. 4 nodes. Okay, well, let's ask for 4 nodes. Let's set 32 tasks per node. That's simple enough. 32 tasks per node. The last bit's a little more complex, ensuring an even distribution across the 8 NUMA regions on the node. Okay. If you think about it another way, what we're really saying is we want to make sure that the tasks are spaced evenly across the entire set of cores available to us. So we can do that by saying, well, let's have 16 tasks per socket. That's fine. Now we're saying we want 16 tasks on one CPU, 16 tasks on the other. That's even. Now let's make sure that they're spread evenly across each of the CPUs by adding an even further level of refinement, which is number of CPUs per task, and we'll set that equal to 4. That means that the first 4 CPUs will go for task 1, which is probably just going to run on the first of those 4 cores. Then we're going to, oops, I actually didn't need that, do I? And then we're going to basically reserve blocks of 4 CPU cores for each task. And because it's only going to be running on one of them, this is us making sure that we're spreading those tasks evenly. And if you multiply these through by one another, you'll see that we're still reserving, if you like, the full 128 cores on the node. And that means that we should be spreading those tasks evenly across those NUMA regions. Okay. This is also important in the context of OpenMP. I've mentioned a couple of times here. Really, the CPUs per task is what's important here, as well as threads per core. So if we set the CPUs per task, then that gives us the ability to say how many CPUs we want to be. Oh, okay. So the CPUs per task option says that for each MPI task, we're going to ask Slurm to reserve this many CPU cores. It's kind of there's some slightly ambiguous naming there. Like it says CPUs per task, really it's CPU cores per task that you're reserving. So when you're asking for 4 CPUs per task, it means every task that Slurm places on a node is going to be put down on, say, first of all, cores 0, 1, 2, and 3. And probably that task will just run on CPU core 0. And the next 3 cores that it's been allocated, if you're just doing this under population, will be doing nothing at all. The next task will be positioned on CPU core 4, because remember 0, 1, 2, and 3 were allocated for task 0. So task 1 is going to be allocated cores 4, 5, 6, and 7. Task means MPI process in this context, yep. Okay, great. So that's okay, you understand that? Just to make sure before I move on again, I just want to make sure everyone's on board with this. Okay, great, perfect. Okay, yeah, so this is something, yeah, these are things that not everyone has to do. Not everyone has to underpopulate their nodes. Not everyone runs with hybrid MPI and OpenMP. And you generally don't need all of these options too. So what we would do if we were running with MPI and OpenMP threads, what we then want to do is we want to be putting our tasks down on the nodes so that they're spaced for each of those tasks threads to live in between the MPI tasks. So here's an example here. We're going to imagine that we're running across 2 nodes with 8 MPI tasks on each and 16 OpenMP threads per MPI task. So that means we want to just say, let's have 2 nodes. It's easy enough to do. We'll just say nodes equals 2. Then we want to have 8 MPI tasks per node. That's also simple. We can choose that. And then we want to have 16 OpenMP threads per MPI task. What's important here is that if you multiply 8 by 16, that's 128, and that ensures that we're going to be using all of the cores on the node. We're just going to be positioning the tasks 16 cores apart from one another. So we're allocating blocks of 16 cores at a time, each block going to one task, to one MPI task, and those 16 cores are going to be used to run 16 OpenMP threads. Something we want to do is this option here, sbatch threads core equals 1. And that means we do not want to multi-thread or hyper-thread if you use hyper-threading as your terminology. We don't want that. We just want one thread to run on every core. And then the last thing to change, of course, is OMP num threads. If you use OpenMP, you know all about this. That's us saying we want those 16 threads to launch. So we're launching 16 threads, and they're going to run across those 16 CPU cores. And that's happening 8 times on every node across 2 nodes. Something to note when you're doing this is that you remember there are 8 newer regions per node, 4 on each socket, 4 on each CPU core if you want to think that way. There are 16 cores in each region. So that means that when you're doing shared memory programming with OpenMP threads, like you don't want those groups of threads to lie over more than one NUMA region, because then the distance to the memory they're accessing could be increasing. So to keep things efficient, you really want to be running with 16 or fewer OpenMP threads per task. So really, you've kind of got 4 options on how you divide your tasks and threads on each node. Every time you want them to multiply together to give you 128 cores, because that's how many cores there are on the node. But it comes down to 8 MPI tasks, 16 threads, 16 tasks and 8 threads, 32 tasks and 4 threads, or 64 tasks and 2 threads. And that means that you never have fewer than 1 task per NUMA region. So your MPI tasks aren't spreading over multiple NUMA regions, which you definitely want to avoid. I've shown you that everything comes into this these Slurm files. So you can always take a look at these with cat, do cat, or you can do less, or you can do more. That's the merged output of standard out and standard error. You can choose, if you want, to put them into other files, so you can separate them. If I vim my script, you can add more SBatch options. You can choose to have output equals, I don't know, anything you like, slurm output.txt and SBatch -- error equals slurm error.txt. If that's what you want to do, this is at this point what makes sense to you, what works best within your workflow. So those are the basics, if you like, of running jobs. What you kind of do from this point depends entirely on your application. Tomorrow afternoon is a sort of bring your own problem type session. We can either work on a problem that's given as part of the course, or if you have your own code that you would like to try out, you can bring it along. We can help you build it. We can then help you run it. We can help you through all those steps. It's kind of up to you. So in case I do forget, I'd like to say, yeah, if you do want to bring your own code or anything, please, you can absolutely do that tomorrow afternoon. We can work through that with you and help you write your job scripts or whatever else may be necessary. Other things which are useful, so interactive jobs I think are very useful because this is the debugger's course, so this is the programmer's course, the software developer's course. I imagine you at some point will be wanting to do small test runs. Running an interactive job is a very easy way to do that. Means you can start, stop your job, see the output you get directly. So for example, I'll just copy all of this. I think this should work, and I'll also just change the QoS to reservation, and I'll run the reservation. So this essentially does the same thing. These are all the same options that you would be giving to your batch script, but we're just providing them to this new command, salloc, so slurm allocate, and we're saying to it, just allocate what we're asking for here. Allocate us 2 nodes on the standard partition under the reservation QoS, because we're asking to run on this course's reservation. Give us 2 nodes with 128 tasks per node, 1 CPU per task, all the same options as before, for a maximum of 10 minutes. And if I press enter, it will tell me pending job allocation queued and waiting for resources, being allocated, waiting for resource configuration. And now it's going to tell me nodes 001256 and 001257 are ready for the job. I think you should have, okay, no we don't, so let's do module load xthi, just as we would do in the script. and then we can just do S1 X THI, and that will run it interactively. And we should see in a second there's the output from it, just as before. And then you can do exit to relinquish your allocation. Another way you can do it is to use S1. So I said at the beginning, you can use these similarly, but a little differently as well to run interactive jobs. So if I do very nearly the same thing as before, do pty bin bash, I think this is everything that's needed. So also starts me running in an interactive job, except that it's now actually going to place me on the node itself. So before I did salloc and it just allocated me the node, but I was still working on the login node and I had to S1 to get the job running on the compute node. When you do S1 to start an interactive job, it instead actually takes you through and places you and logs you in to the compute node to get working. There was a question. Is there a time limit for running interactive jobs? There is no time limit that's any different from what you would get for a non-interactive job. So it still governs just the same as whatever your QoS gives you. So if you're running under a standard QoS, that's 24 hours. Obviously, you may not want to do that. If you start an interactive job that runs for 24 hours and you do nothing in that time, that's 24 hours doing nothing. Generally, I've never found myself needing to allocate nodes for an interactive job for more than 1 hour or so, because I want to quickly start it, see how the application fails, and then quit back out again. Yes, and then, yeah, so this is just another way of doing it, and then you can just S1 all over again. Interactive jobs run under loggers. Yeah, yeah, so this is something, yeah, so on Archer2, you can't actually run MPI applications on the login nodes. So if you try to do an S1, it won't work, and there isn't an MPI exec or the like to do it. So on Archer2, for any MPI jobs you want to test out, you've got to get an allocation on a compute node, on at least one compute node to do it. So yes, so you can use either salloc or S1, but the job itself will be running on the compute node. And the QoS, setting the time limits, the number of nodes you're using, the like, is just the same as for a non-interactive job. So the short QoS may also be of interest. If I go back to doing, let's go back to doing salloc. I'm just going to change the QoS to, let's go back to standards, because I think this will show it fairly well. So I'm asking for 2 nodes on the standard partition, standard QoS. I'm not using the reservation. So this is just going into the melee of everyone else's jobs. And I'm asking for 10 minutes. Let's see what happens. So, oh, okay, it started straight away. So at the moment, then, I guess the system isn't that busy because that job started straight away. It may be that if you were to do this, and you can do this for, again, a non-interactive or an interactive job, what you can do, if you find the system is busy, but you really just need to run a quick job just to see how something crashes, see what happens. So again, this is very good if you're doing deep debugging type work, is you can run with the short QoS. This limits you to fewer nodes, I think to 60 possibly nodes. I'm not sure on that, we can check in a second. And it also means you can't run a job for more than 10 minutes. But if you use the short QoS, so you just set QoS to short and make sure that you're not running for too long, that exists on the system, and it has a reservation, which you don't need to mention, you don't need to worry about that. It will start running probably very quickly or straight away, hopefully, if no one else is also using them. So the short QoS is a great way to just quickly get a small job running, just to see if it works. Finally, we had a question about using the serial nodes, using the data analysis nodes. So I'm just quickly showing you here the Archer2 documentation on the left. And there's a section on this, if you go into the user and best practice guide on data analysis. And again, it's just a matter of choosing your QoS information, really. You will generally do this a little differently. So if you want to run an interactive session on the data analysis nodes, here you can see, let me make this bigger for you. Here we go. You would instead do something like this. So you'd still do SLOC, you choose however long, 20 minutes here. Then you choose the serial partition, because you aren't running on a standard nodes now, you're running specifically one of the data analysis nodes. QoS is the same, serial. You provide your account, which is going to be TA051. You're probably going to be running with one task only, so you would just, because you're going to be running a serial program probably on here to do your analysis. And then what you can do that's a little different is you can change the amount of memory that you allocate for your job. And that's because the serial nodes, remember, the data analysis nodes are shared. So you can have multiple users running on the same node. But it may be that what you want to do, the work you need to do here, needs perhaps more memory than 128th of the node's memory. So you might want to request more memory. Maybe you want 8 GB of memory for your task. So you can specify that here. I mean, just to show you, let me just quickly show you what this looks like. Account equals TA051, and tasks equals 1. Don't want to do anything in parallel, and let's just ask for 8 GB of memory, the exact same way. And that's us ready to go. And again, you can use srun in the same way as before to start an interactive session. Really, there's not much difference unless you do specifically want to be running on the node itself. Okay, so yeah, there's a lot here. We haven't talked about using the high memory nodes. To do that, you would just change your partition to high mem. That's all it is. You might want to use a different QoS to run long jobs. You might want to run job arrays, where you use the same executable to do the exact same thing, but with potentially many different sets of input data. And you might want to run sub-jobs. So you might want to reserve, say, one node, but have four different simulations running on that one node, as an example. So there's a lot here. Again, it really depends on what you want to do. This session this afternoon has hopefully given you a sort of crash course introduction using this one example of XEHI. But if you need to know how to run something slightly more complex, Archer2 scheduler documentation is all here. This is the page here, and this covers essentially everything we've been talking about, but provides, here we've got the different QoSs. So there's the standard QoS, maximum all time 24 hours. So if you want to do something 48 hours maximum, you go to the long QoS instead. And that's just a matter of going into your JavaScript and changing your QoS here from standard to long and the like. Okay, I've overrun quite a bit there. My apologies for that, but we're still short of 4 o'clock. Does anyone have any questions at this point? Okay, I'm assuming everything's okay then. So that's us done for the first day. We've covered a sort of overview of the of connecting to Archer2, of the system hardware, the different types of nodes and how they connect to the file systems. We've looked at how the development environment works using the modules, the different plugins, using the compiler wrappers, and now how to submit jobs through Slurm. Monica, I understand this remains online, so we can look it up every time. Yes, absolutely. Yeah, the links to this material should be permanent, and YouTube links will be going up some point soon. I hope in the next few days to allow you to watch the recordings if you want of this session again. And as I say, the documentation on the docs.archer2.ac.uk I think goes into a lot more information again on everything that we've covered here. So yeah, absolutely, you can come back and check this out whenever you feel that you would like to. Okay, great. So everything sounds good. So tomorrow then, we'll start off at 10 o'clock again. We're going to go through a couple of exercises on debugging and profiling your codes on Archer2. We'll use some of the tools which I mentioned earlier on today when we were going through the development environment. And then after that, some more general information, some steps you can take to be a responsible user. This does matter. How you can protect your data, which we've already talked about a little bit. Then a bit on using the safe. There are some useful tools on there which you might find handy. And as I say, then in the afternoon, we've kind of got a next steps and then a bootstrapping session. So here, this is where, as I say, we have an example here if you want to try profiling Gromax, I believe it is. We have some sample data and some scripts, and you can just copy those into your directories and start running jobs if you'd like to try profiling them yourselves. Alternatively, if you do have a code of your own that you would like to try start getting going with, you can bring that along and try to build it, try to run jobs with it, and we will be on hand then to provide advice to you there and then if you would like it. Other than that, though, I think we can say that's us done for today. So I hope you found it useful. I hope you found it interesting. Thanks very much for coming along. And I'll just say I hope you enjoy the rest of your afternoon and have a good evening.